What's up, mathletes? Mr. Antonucci here, back at you with another video. And in this video, I want to talk about how to add and subtract expressions involving radicals. Okay, so let's jump in. Now, something we have to keep in mind with adding and subtracting radical expressions is in order to add and subtract, you need to have like terms. And I'll show you exactly what we're talking about. We'll work through three examples here. First one I want to show you, example number one, is if you just have basic problems, 6 square root of 5 plus 2 square root of 5 minus 5 square root of 5. Remember, in math, you can only add and subtract things that have the same name, or that are like terms, in other words. These are actually all like terms because you are adding and subtracting the same square root. You have 6 square roots of 5, so it's like you have 6 of this thing, 6 square roots of 5, plus 2 more, which will give you 8, subtracted by 5 of them, so 3. So when you add and subtract square roots, you add and subtract the number in front of like terms. So 6 square roots of 5 plus 2 square roots of 5, that would give you 8, minus 5 square roots of 5, your answer would equal 3 square root of 5. Now that's a pretty straightforward one. I want to talk about one that is a little bit more complicated because I know you guys can handle it. So example number 2, if I had 6 square root of 27 plus 8 square root of 12 minus 2 square root of 75. Okay, now none of these right now are like terms because none of them have the same square root or the same radicand. However, they are not fully simplified because each of these has at least one perfect square factor inside the radical. So for example, and this is something you have to check for, 27 can be thought of as 9 times 3. Okay, I like to write the perfect square factor first because the next thing I'm going to do is take the square root of that. So plus 8 square root of 12. 12 can be thought of as 4 times 3. I know you can also write 12 as 6 times 2, but 6 and 2 aren't showing the perfect square factor of 12. You have to write it as 4 times 3. And then minus 2 square root of 75 is sometimes tricky, but remember it's 3 times 25. So I'm going to write it as 25 times 3. Okay, and remember, whenever you have a product inside the square root, you can take the square root of each factor separately. So for the first one, you would have 6 times, now I can take the square root of 9, which is 3, and then the other factor of 3 stays inside. So remember, when you take the square root of a number that's inside the radical, it comes out. Plus 8 times 2 square root of 3, because the square root of 4 is 2. Now, when you take the square root of the number inside the radical, it comes outside and multiplies the number that's in front of the radical already, if there's a number there. Okay, minus 2 times, guess what square root of 25 is? 5 square roots of 3. Now, notice they all have a square root of 3. So now they're all like terms. Let's just multiply the coefficients to clean this up. 6 times 3 is 18 square root of 3. Plus 16 square root of 3 minus 10 square root of 3. And since the coefficients or the numbers in front of the square roots are all the same, you can add and subtract those. So 18 plus 16 is 34 minus 10 gives you a final answer of 24 square root of 3. Bippity bop, bippity boop. So in this case, you had to simplify each radical first. So make sure you check to see before you add and subtract if the radicals can be simplified. All right, one more. I'm going to show you kind of a neat thing here. If I have 9 square root of 12 minus 2 square roots of 8 plus square root of 50 minus 3 square root of 27. Now again, none of them at face value are like terms. However, all of them have a perfect square factor. So let's see what that is. Square root of 12, we already did one like this. That's 4 times 3 minus 2 square root of 8. Sometimes it's tricky, but remember 8 is 4 times 2, so you can write it as 4 times 2. Plus 50 is just 25 times 2. And again, I could write 50 as 5 times 10, but that's not going to show the perfect square factor. We want to set these up in terms of factors that have a perfect square in them. Okay. Now, the first one, 9 times the square root of 4 times 3. Square root of 4 is 2, so it comes out and multiplies the 9 and gives you 18. Okay, I'm going to skip a middle step here. I'm not going to show the 2 multiplying the 9. I'm just going to do that in my head, okay? We want to work up and be able to do some mental math here. So the square root of 4 is 2. The 2 multiplies the 9, gives you 18. What would the next one be? Square root of 4 is 2, multiplies the 2 out front, so you'd have minus 2. Oh, not 2. Minus 4 square root of 2. Third one, square root of 25 is 5. There's no number out front, so you just write the 5 there. There's nothing to multiply, square root of 2. Minus, and then this would become 9 square roots of 3, because the 9, the square root of 9 is 3, multiplies this 3 here. Okay, now we can take a peek at like terms. Notice the square roots of 3, there's 2 of them, and that will become 18 minus 9 is 9 square root of 3. And then there are 2 like terms that involve a square root of 2. So be careful here. You have minus 4 square root of 2 plus 5 square root of 2. Minus 4 plus 5 gives you 1 square root of 2. And it's positive, so you'd have plus square root of 2. You don't need to write the 1 there, but if you did, it wouldn't be incorrect. Okay, and then that's our answer, 9 square root of 3 plus 1 square root of 2. You cannot add the square roots and make that like square root, somehow something square root of 5. Don't do that. I've seen students do that in my years of teaching, and just be careful. That only works if you're multiplying. You can only multiply the insides if you're multiplying. You can't add or subtract the insides. All right, so hope that was helpful. If you have a problem that you'd like me to go over, add it in the comments and maybe I'll make a video about it. And also make sure you subscribe to the channel and hit the bell for notifications. All right, guys, Mr. Antonucci out.